G'day everyone, welcome back to the Perkins Engineering YouTube channel. Thanks again for an enormous amount of support after our last couple of videos. We've switched it to Saturdays or Sundays, depending on when we get the videos filmed, when we'll be loading those videos. Previously they've been on Tuesdays, and we think that it's probably better suited for the weekends, especially with so many people in lockdown. The weekend's a bit of a better bet, we think. So thanks again for the support, all the feedback on the audio with Larry in the Volkswagen video. We're not video makers by trade, but we'll see what we can do to improve the quality of the audio. It's a pretty low budget operation here, but we're doing our best to bring you guys some pretty cool content. So thank you very much for the feedback and thanks for the support. In this episode, I wanted to have a look at how the rear driveline works, because when we put some stuff up on our rear end in the 93 car and indeed the 2003 car, there's a lot of questions on how it worked, and I guess we took for granted how many people knew how all this rear end works with the cambered rear end. So what I've done is I've walked around the workshop and found as many bits and pieces as I can to try and show you how the rear end works, and I'll do my best to sort of explain how it all works and piece it all together. And I guess it starts here with the tail shaft. So tail shaft runs down the center of the car. It's connected directly to the back of the gearbox, which is obviously copying the power from the engine. And then that comes to this diff sensor here. It connects with a yoke, Perkins Engineering yoke. Then it works out how to drive out to the rear wheels. It's got a spool in the back here, which effectively connects the diff gears to then the axles, and the spool means that both axles turn at the same time at all times. So many road cars and other cars will have single spinners, as they're known, or where the inside wheel turns at a different speed to the outside wheel, and vice versa. So for those of you that have ever seen a supercar getting pushed around the pit paddock or in and around the pits and you hear them clunk, that's because the two wheels are turning at the same speed, and it's a protest because an outside wheel always has to travel further than an inside wheel. So that's how that works. So what I wanted to look at today specifically is from the spool, from the diff here, out to the hub, if you like, and where we get the camber. So I'm going to try and run through the various parts that are involved there, as well as talking and filming at the same time. So bear with me and we'll see how that goes. Okay, so the first piece of the puzzle in getting the drive from the diff out to the rear wheels is with the axles. So one axle is shorter than the other, one's longer obviously, to match the offset in the gear set from the spool. So 31 splines on our spool slides into there, and then 33 splines outboard. These axles were originally made in America by Summers Brothers. We used Summers Brothers for a long time. They were a bulletproof axle, and more recently we've actually been getting these made locally by Race Products, so having great success with them as well. So from the axle, we then go to the CV joint. So I'll bring that into play. So this is our trusty CV joint we've used for many years. Obviously the splines on the inner drive match our axles, 6 balls, all the mounting holes that match up to our next part, the CV flange, if you like. This has been a trusty part for us from since the cambered rear ends came in the late 80s, right through to around about 2007. We used this setup the whole way through until we went to tripod journals and things when the technology started to get a bit better. So this is where the camber comes from, because this allows the axle to stay true, but then the hub can move to a preset angle to give you some camber in the rear end. I'll show you how that works. The axle slides on there, gets a circlip on the back, and then that forms the first part of the drive to the hubs. I'll bring a few more props in now. I've had to sort of round up a fair bit of stuff from around the workshop. All of our new stuff and service stuff is all in cars, kind of ready to go. So I've had to find a bit of junk around the place, and so I've been able to do that, and now I can show you how all this works. So these are the next parts that all create drive out to the rear wheels. I've grabbed a couple of different hubs. So this is a center lock hub. You see it's got the big spindle here for the main big center lock nut, the drive pegs here to help drive the rear wheels, and then the splines here to match our short shafts, which I'll run you through. So that's a center lock hub, and then this is the same thing but in 5 studs. So no drive pegs, the wheel studs act as the drive pegs. No big spindle hanging out the middle, just a thread in here for a aluminium wheel guide. And then this is the outer hub. This is painted red because it's crack test failed, so no good, hence why it's not on a car. And the same with the outer hub, it's got a crack through it, but we would use this kind of a combination for pit stop practice so that we don't wear out good racy stuff. So this is the outer hub section, the big bearing. You can see on either side there's big bearings, cones and cups. SKF bearings we always use and had no dramas with. And then this little bad boy does quite a lot of the heavy lifting. This is what drives the basically the drive to the rear wheels from the CV joint out to the wheels. So quite often you'll see in the older times rear axle failures. There's either the long axle or this little short stubby axle, and that axle slides through our CV drive flange, and that effectively bolts straight onto the CV joint, which goes through there, and then that gets poked through the hub, through there, and then joins all that up with a washer here and a big nut, which is probably one of the tightest done up nuts on the race car, and that keeps that hub assembly together, enables you to get all the preload on the bearings with some hub spaces in there as well, and that's the rear hub setup and assembly. So that's the sort of mechanicals and the moving parts. And then we spoke about the camber wedges. So I'll bring the camber wedges into play and we'll run through how they work. So these are 2 left-hand rear camber wedges, and they bolt straight up to the hub on one side, and then on the other side they mount up to the diff housing. So these need to be heated up to get them in the right spot, but effectively that bolts through here, which kind of sits over the top of this section here, and then the diff housing would run through here. And then how does it achieve its camber? Well, that's in the design, so it's hard to see by the naked eye, but this one is marked up 1.5 degrees, which is camber, and it'll have standard toe, which will be 2 mil toe in. And if we were to put that against the ground, it's a bit tricky to see, but you'll see that it's not at right angles. So that's where the camber comes from. Effectively, that then sits square to the diff housing, and it creates a camber angle. So for example, this runs true to the hub, and then there's a little bit of camber, which I've exaggerated to show you how it works, and that's effectively where the camber comes from. This is then another camber wedge, which is 2 degrees, so 2 degrees negative camber and standard toe. So if you wanted to make a 1/2 degree camber change, you need to drop the diff oil, which would typically be hot, and then pull that out of play and put this camber wedge in. So the toe adjustment's machined in on this plane, and the camber adjustment is in this plane. So very complicated when it comes to fine tuning race cars, especially for those that are familiar with independent rear ends. Obviously changing toe and camber is a lot easier with tie rods and things, but this was a very trusted, sturdy setup that lasts us for many years, and you know, very cost effective, would do quite a lot of miles, and yeah, it was fairly bulletproof. Like I said, the first thing that would fail would traditionally be axles and these short axles, and they would just crack through the splines based on you know, a lot of load and drive that goes through there. So quite often, if you had a rollback start. If you were starting on a hill and you dump the clutch, you know, the twist that goes through the driveline, tail shaft diff, it just wants to break. So that's the rear end setup, and I hope my explanations all made sense, and you know how our cambered rear ends work.